Hi, everyone, and welcome to the 2018 Code Talk series. The Code Talk series is co-sponsored by ODTUG and IOUG and provided by Oracle Developer Advocates. Today's webinar is JSON and PL SQL, a match made in database, presented by Stephen Feuerstein of Oracle Corporation and Darryl Hurley of Implestrat. If you have any questions at any time during the webinar, please type them into the questions box and they'll be addressed as they come in. This presentation will be recorded and available to everyone through the Code Talk page of the ODTUG website. So welcome, Stephen and Darryl, and thank you both for being here.
Thank you.
Thank you so much, Karen. So hey, everybody, Happy New Year. Hope 2018 is way better than 2017 in every possible way. So my name is Stephen Feuerstein. I'm the Oracle Developer Advocate for PL SQL, roughly speaking, a PL SQL evangelist. I've been working with PL SQL pretty much nonstop and almost exclusively since 1994. Lucky me, because PL SQL just gets better and better. And everything we learned in those early days, almost everything we've learned and everything we've applied still works just fine. But there's also new stuff. And we're here to talk to you about some of the newest stuff in PL SQL having to do with JSON, JavaScript object notation. So the main presenter for today is Darryl Hurley with Implestrat. And the reason he's the main presenter is that he's been diving deep into JSON and Oracle database functionality. We held a session last year that focused on the SQL side. And as you're going to see in 12.2 of the database, we added features specific to PL SQL. So this session is intended to focus around the PL SQL features. But if you've got questions on any aspect of JSON and Oracle database, certainly this is the place to ask about them. In general, just a little comment about the Oracle Developer Advocates team. Our job is to help you be successful with Oracle technology, especially Oracle database technology. Hopefully you're following us on Twitter, checking out our videos on YouTube, etc. We should be really easy to find. Just search for us. And Darryl is easy to find as well. So Darryl, tell us about yourself.
I've been doing Oracle PL SQL development for far longer than I care to remember, about 30 years worth. All relational database work. Recently, the XML craze came and kind of faded, and now it's been replaced by the JSON phase. So I decided to get involved in this and see what it's all about, because a lot of developers where I work are eager to move to JSON. So I wanted to check it out. I figured PL SQL and JSON would be a good way to do it.
Great. I'm sorry, I lost the share there. Excellent. And we all benefit from it. So he's been publishing actively on his blog and writing live SQL scripts and more. So great source for information on this. All right. So why don't you start off with a kind of general introduction around JavaScript, JSON, and features in the database around SQL, and then we'll dive into the PL SQL side of things.
All right. General description. JSON can be stored in the Oracle database as straight text fields, and you can manipulate it using PL SQL packages and functions. There's a couple main ones: JSON Element T, which deals with JSON Elements, of course; JSON Object T, which deals with all of the JSON objects; JSON Array T, which manipulates JSON arrays. There's also a third one, JSON Key List, which will give you a list of all the keys in a particular JSON object. They're all available in Oracle in 12.2 and higher, and we'll be doing demonstrations of them in a few minutes.
Cool. So we've got a bunch of new object types in PL SQL. So just to be clear, the native PL SQL language hasn't changed, and there's nothing native in the syntax of the language. What we've done is add a number of object types, Oracle PL SQL's version of an object-oriented approach within the relational database. And those object types have all the methods and the static functions and procedures to help you manipulate JSON. So before we dive into that, I think that the biggest question that a lot of us might have, Darryl, is why do we need this? How would people use this? What are the core use cases for using these PL SQL object types for JSON manipulation?
The core use would be accessing the data directly from the database. If you have JSON stored physically in Oracle, there's no quicker way or faster way to get to it and manipulate it than PL SQL, because PL SQL is right next to the database. It's actually embedded in the database, so that's the place to do all the fastest retrieval and manipulation of JSON.
Now the retrieval you're going to be doing through SQL, right? Select statements. So what do you need PL SQL for that you can't do, let's say, with straight SQL and JSON?
If you want to do in-depth parsing of your JSON and or updating of your JSON before you send it out to the client, then the best way to do that is PL SQL. SQL itself can do some of it, as we showed in the last code talk, but PL SQL can do the more in-depth work.
All right, and that's what we're going to see today, right?
That's correct.
But before we do that, I've got a great question that just came in. Can we add these object types like JSON Object T and packages back to version 11 so that we can use it right away? Wow, that is a great, wonderful thought. Take these pieces of code that are stuck in Oracle 12c and make them available, like export the object types perhaps, and then put them into an 11G database. Sounds really interesting. No possible way is that going to happen. This is all pretty tightly knit together. And in general, there are very few instances where Oracle will publish new functionality into a database version and backport it into previous versions. It's very, very rare, and certainly not in this case. So I'm sorry, but when it comes to manipulating JSON natively in the database, you will need to get up to 12.1 for the SQL manipulation, 12.2 for PL SQL. But prior to Oracle 12c and still in existence, if you're working with Application Express or you have Application Express installed, then there's a package called apex_JSON that does provide a lot of similar functionality. It was written by the Apex team, Application Express team. In addition, there's an external package or utility, I haven't actually used it myself, called pl/JSON. And I believe that's available on GitHub, and that will give you some other JSON manipulation capabilities in your database, I believe even in Oracle 11. So this functionality, you've got to upgrade to 12 and 12.2, but there are options today for manipulating JSON, even if you're not on Oracle 12c. Next. Darryl, should I hand it over to you in terms of sharing your screen and showing some demonstrations?
Please do.
Okay. So I'm going to find you attendees. All yours. In the meantime, I'll check questions.
All right. The first object we're going to talk about is this one right here, JSON Element Key. That deals with elements. JSON is all about key value pairs. On the left side is the key. The right-hand side of is the value, denoted by a colon. JSON Element T deals with everything on the right-hand side, which is the values. So for example, it can store an actual JSON array. This one is a simple array, numeric 1, 2, 3, 4, 5. This one here is another JSON element. It's a full-blown key value pair with the squiggly brackets and the quotes. This one here is an array of key value pairs, and you can also have JSON embedded in JSON. So here the key is name, and the actual values is another key value pair. So
Why, that's just crazy.
I agree. It's easy to get lost. So I'm going to run this code, and it's not going to show very much. It's just going to simply show that it actually compiles. And that's important because you can't throw invalid JSON at any of the JSON objects, of course, because it won't know what to do with it, and it'll throw the error shown below.
Great. And Darryl, before we move on to the next example, another question did come in, and it's one of those fundamental questions that would probably be helpful for our 145 attendees. Why store JSON documents in Oracle database? The question is just in a database, but I assume they mean an Oracle relational database when it's document data.
It's document data, yes, but if you store it in an Oracle database, you get all the benefits of transaction control and backup and recovery, and various ways to store it to make retrieval quickly. And you can also take advantage of other Oracle features if it is stored within the Oracle database itself.
That sounds good. And I'd also add that, you know, the objective of implementing JSON support inside Oracle database is not so much to replace document databases. Document databases have a use case that Oracle relational databases might not always fit. But what we want to make sure is that if you happen to need to work with JSON, or your users need JSON data, or your UI developers want to work with JSON data, that you don't have to abandon Oracle database to do that in an effective way. One of the other members of my team, Connor McDonald, down in Perth, Australia, ran into a situation where the company he just left to join Oracle, he was talking to some of the developers after he'd left, and they had mentioned that they had other developers in the organization who were busily working on installing MongoDB. Why is that? Well, they had a requirement for manipulating JSON documents. And they said to themselves, well, I guess we should install MongoDB, as opposed to having just upgraded to 12.2, taking advantage of that functionality. They had no idea it was there. So the bottom line is that if you're working in an enterprise in which Oracle is already installed, and you've upgraded to 12.2, which more and more companies are getting done, then if there are JSON requirements, you don't have to say, oh my gosh, we need to install a different database technology to meet your requirements. It can all be done within the Oracle database and done in a very powerful way because of the integration with SQL and PL SQL. Okay, back to you. Hopefully that was a decent answer for the questioner.
Okay. So since JSON doesn't have any actual structure denoted in the database, you can't go to the data dictionary. All of the JSON objects, including JSON element, have to be able to parse themselves to figure out what they contain. So what I've done here is I'm going to create 3 simple JSON elements, call a procedure called whatami, which is right up here. The first thing it's going to show is the actual size of that JSON element, i.e. the amount of elements it contains. And that's using the vElement.getSize call, which is part of the JSON element T object.
So that's a member function of the object type.
Correct. And another function, member function, is object. So you can check if the element is actually an object, or you can check if the element is an array. So when I run this code, check the output over here. The first thing we sent it was an object with a size of 1, then an array with a size of 5, and last but not least, an array with a size of 2.
And is there a difference between what size means? So the size is simply the number of elements in it. I can see how that makes sense with an array, but what does it mean to have a size of an object?
It's the number of elements. So
Okay.
For the first one, it has a single JSON element called name. So the return value was 1. And then the next one, it's an object. So it returns the number of objects in the array. Sorry, it's an array. So it returns the number of elements in the array, in this case 5. And in the last case, it has 2 because there's 2 elements in the array. Arrays are denoted by the square brackets in JSON.
Great, thank you.
Another interesting behavior of JSON objects, including JSON element T, is they can be quite forgiving. For instance, here I'm going to do a 2-number call when I'm passing it in a JSON object that is obviously not numeric. So when I run the code, it doesn't fail, and I get the output. It tells me the name, but it returns a null when I try to do a 2-number on that. So that's the default behavior. If you actually want it to outright fail, you call another member function for JSON element. It's called the onError, and you can stipulate that if you give it a number 1, that means it actually will fail when it encounters an error. So we get the error shown below.
So this is really important to emphasize here, that the default behavior of the object type API for JSON objects is different from the normal behavior of PL SQL. In PL SQL, if you have a conversion error, for example, value error, I'm trying to assign ABC to a number, it throws an exception always. But the default behavior in JSON, as I understand it, correct me if I'm wrong, is that it will be silent, it will return null. And it's up to you if you want to escalate the errors, and you can do it on an element by element basis. Sound right?
That's correct.
Oh, great.
One thing vElement or JSON element can't do, because it's the sort of the lowest level of the hierarchy, is it can't directly run get size or get number or get value directly from itself. So in this particular case, if I try and do a get number to get array element number 1 from this array, it's not allowed. JSON element can't do this part. The other object types that we're going to talk about later need to be used to do that sort of interrogation.
Okay. And Darryl, we had one quick question. Why is the behavior different in terms of the error management? I suppose that's not a question for you. Why did Oracle do things differently? My assumption, and you might have an insight on this part of it, is that it was done this way because that's the default behavior with JSON documents in general, so that we wanted to implement an API that naturally fit with the way people were already working with JSON. And then if you wanted to change that into more of the normal PL SQL environment, you could. What do you think? Sound reasonable?
That does sound reasonable. And actually, one of the ways JSON processing is made faster is it doesn't do this error checking. It just returns no.
Gotcha. Right, raising an exception is definitely slows things down. And sorry, one other follow-up comment to the question before about why store JSON in the database. I don't know if I'm pronouncing it right, but Jis said you could also parse the JSON document and store it relationally. So maybe we should just touch on that for a moment. So I've got that. Obviously, if you're working with the UI developers, almost certainly they're working with JavaScript and they're working with JSON, JavaScript object notation. So they're going to want to pass JSON back to the database one way or the other. And so the question is, why keep it as JSON? Why not tear it apart and store it in your different relational tables? Thoughts on that?
You can do that with the PL SQL functions and or the SQL functions. And you can even do the translation on the way out with some of the actual SQL functions like JSON table that we demoed in the last code talk.
Mm-hmm. Okay, so it seems like you can do that. The question would be, why wouldn't you do that? And I think the part of the answer would be that one of the advantages of JSON is that it's not like a relational table, and that every row in a relational table has the same columns. It's very structured, right? And the whole point, the whole driver for a lot of developers around using JavaScript and using JSON and having like JSON all the way down the stack is that it's unstructured data. If I want to add a name value pair into one document and it's not in other documents, I can. So there's not necessarily consistency between every single document and say every row in the table. So the nice thing about that is that it allows for a lot of variability in those structures. So I would say that if you have JSON documents coming in from the front end and it's always the same, they're always the same 5 name value pairs and so on and so forth, then it might make sense to tear it apart and store it relationally. But if you've got JSON documents coming in as all are part of that data feed that can be highly variable in terms of what's in them, that's where it might make sense to simply save it as a JSON document and then use the JSON features to be able to go through that, find the variations and pull out the different pieces of information.
Yeah, that's true, and that's where the error behavior, the forgiving error behavior would help out too, because you can pretty much parse anything and you don't have to worry about failures if the documents differ.
And I'll just keep asking you the questions as we go, and maybe we'll get through your presentation. I don't know. The next one is there any benchmarking testing to compare JSON retrieval or creation compared to relational retrieval in terms of performance? Obviously, that's...
Not yet that I've seen, but I do have that on my plate to start getting to do for my blogging.
Great. So I don't have that information, neither does Darryl right now. Probably the best source of that would be to go to the JSON blog, which is on blogs.oracle.com. And I'll make sure we give you that URL before we head out today. Okay, go ahead.
Okay, one thing Element can do, JSON Element T can do, is it can display its whole contents simply as a string, as shown there. It simply shows the full contents of the array, but it shows it as text. All right, that's JSON Element T. Now we'll move on. Next up, first I'll clear up my DDMS output so we don't get confused. Next, we're going to talk about JSON Object T. This is one step up from JSON Element T, and then it can do more actual work on the data. So it can actually do get string or get number or get value from the object. So you'll recognize this call to JSON Element T from the previous examples. This call will be slightly new because I'm then going to transfer that particular JSON element to be a JSON object. So now I can do more manipulation, and the simplest manipulation to show is getting the string value. So I'll run this code. Yep, have to run the whole section. There we go. So it shows the value of Marty, and notice it dropped the actual key, so it didn't say name : Marty. JSON object is the only function or within the JSON objects that can actually check what keys it contains. So I'm going to parse this particular object, which has a single key called name. Then I'm going to make a call to get keys, which is another function in the JSON object T. And I'm going to load that into a PL SQL array called JSON key list. And I'm going to output the list of the keys. And I'm also going to do a get string to get the value of each of those keys. In this particular case, it's going to be a little bit boring because there's only one key with one value. So that's actually one of the handiest features of JSON Object T, is it can interrogate what keys it has and then go and interrogate the values of those keys. JSON Object can store all types of data similar to JSON Element, except it has to be key value pairs. They can be embedded, they can be arrays, they can be even JSON value embedded in other JSON values, but it has to be key value pairs. And of course, it has to be valid JSON. We're a little bit unforgiving in this area. Now here's a demonstration of why it has to be key value pairs. Excuse me. This is a valid JSON element. It's a JSON array, but it's not in a key value pair. So JSON object won't allow parsing it. It has to be a key value pair. JSON object can also interrogate itself. You're going to load these three JSON objects and call a procedure called whatAmi, which is right here. First thing it's going to do is show its size and then check if it's an object, very similar to the code we did for JSON Element. And similar results.
Let's see, before you move on, let's just, let me just grab a couple of questions before I lose it. One person, David, wrote, for relational tables, we can index columns for faster retrieval. What about storing JSON data? Do we have the ability to index on elements of the JSON data?
Yes, you do. You can do it two ways. You can index directly on a SQL JSON value call within the actual data to index on the actual element. Or you can, if you apply a data guide to your JSON table, you can actually make columns in the JSON data be physical columns in the table and index on them. We won't be covering that today.
Yep, okay. And a question, I presume a lot of context switches when using the JSON logic. Is that correct? So I'll give a first answer. Sorry, go ahead, Darryl.
Yes, context switching will be something to keep track of when you're doing this.
Right, so every time you're calling one of these methods or functions and procedures in the object type, you are switching from SQL to PL SQL. But well, actually, sorry, when you're executing the object type methods within PL SQL, there's no context switch there because you're not switching to SQL. When you execute the SQL statement to grab your data back into your program to manipulate it, then you'll see a context switch. But in general, the calls of the object type methods and procedures should not do that. No.
True. So we're going to talk about forgiveness again. JSON object is just as forgiving. If you make a call on toNumber on a string, it simply returns a null. But if you wish, you can tell it to be unforgiving using the onError procedure. And it'll actually throw a PL SQL error, which you can then trap as an exception if you wish.
And Darryl, a question that might help for as we move through all these other examples. Why would you use JSON Element T instead of JSON Object T?
JSON Element T is best used for low-level processing on elements when you don't necessarily have the key. So if you need to process strictly a JSON array, and maybe it's just all numbers or maybe all string, you wouldn't necessarily even know the particular key or the name of that array or object. That would be the best time to use it.
Okay, thanks. Is it possible to use the PL? Sorry.
Go ahead.
Is it possible to use the PL SQL JSON features in Pro C applications? C++ applications.
I'm assuming so because you can use everything else from Oracle in there.
Don't see why not. Yep.
Haven't written Pro C in a long time. JSON Object is also quite forgiving if you're looking for keys that actually aren't in the data. So this particular object, the single key is called name, and then this one is called numbers, and this one's called stuff. When I get up here to the sub procedure, I'm always going to look for the entry called name. So when I run this, it doesn't outright fail. It just shows me the ones that it can actually find, in this particular case, Marty. Can even forgive incorrect type conversions as shown here. I'm going to do a get string, even though in this particular instance I'm going to send it an array, which isn't a string. In this particular case, I'm also going to send it an array, which is not a string. Doesn't fail. It simply returns null. So that is handy if the JSON you're being sent is quite unstructured and you never really know what's in there. You can just search for what you know about and you won't get a failure if it's not there. Of course, you can also tell it to complain. In this particular example, I'm going to set the on error to be level 1, which means it will complain when I try and do a get string on an object. Or sorry, a get string on an array. Now when I run that, it's going to tell me it tried to do select a value of a different data type. In this particular example, it tried to get a string from an array. All right, now we're going to see how the code can actually check what it contains prior to doing any calls to avoid any conversion errors. So I'm going to build those same 3 JSON elements, and I'm going to actually check the key up here. I'm going to see if what I just sent is a scalar value, and if it is scalar, simply means it's a single value, not an array or not another object. And then I'm going to convert the object that I just got sent into an element, and then I'm going to check if that element is a string using all native JSON PL SQL calls, and if it is, then I'm going to output the value, and if it's not, then I'm going to say no, that's not an object or an element and a string, which means I can't even do a toString on it. There's the value. So the element returned was Marty, and when I returned the value from an object, it was also Marty. This actually shows another important difference between JSON Object and JSON Element. When you deal at the JSON Element level and you display the value, you get it as valid JSON, which means it contains the quotes required by JSON. So be careful of that in your processing.
We just had a question come in. Can you create constraints? I assume that means create constraints on the values that are assigned in name value pairs in the JSON document?
No.
I don't think we can. You can use DDL check constraints within the JSON document.
I don't believe so, no.
Anyway, who wants to do that with JSON anyway? The whole idea is do whatever you want, put in whatever you want. Who cares?
That's correct.
Whether we like it or not.
Next up, we're going to look at how you can actually extract values, and a simple example of just extracting straight values from an object. In this particular case, I'm going to do extract the value based on the key. And when you run the get call in VObject, it simply gets the element. There's other calls for get object or get array, but if you use the base behavior get, it defaults to element. Also note that when I pass it in, I'm actually passing the name. So this sort of simplistic processing is great if you happen to know the name of all of your keys. This particular processing wouldn't be too helpful if you didn't know the name of all the keys. So there you go, it displays the values. And again, note that because I use JSON element, it slaps the quotes on it.
And sorry, by the way, I have a question here related to the on-error call. So do we have any session level or database level property for not suppressing the error on JSON? And I believe that's not the case. It's really on an individual element basis that we have to do that.
That's correct. All right, now, JSON objects can also be arrays. So this is where I'm going to introduce the latest object type. It's JSON Array T, which handles arrays. So in this particular processing, I'm mostly going to focus on processing of this entry, this JSON object that is an array, and this JSON object that is also an array. When that gets passed to this procedure, the first thing I'm going to do is I'm going to extract it down to an element, and I'm going to check if that element is an array. And if it is an array, then I'm going to parse it down to be an actual JSON array T, which means I can then manipulate it as an array. Simplest thing to do with an array is simply to check the size using the getSize function call. And if I find out that that particular element is not an array, I'm simply going to say so. Pretty straightforward processing. So tell us that the numbers is an array of size 5, stuff was an array of size 2, and name, the first object passed in, was not an array at all.
And Darryl, another question came in. Can we validate JSON using JSON schema similar to XML schema? Are you much familiar with that?
You mean to validate if it is indeed valid JSON?
Or the right, I assume the right structure conforming to a schema.
Conforming to a schema, I don't believe so, no.
I think I'm not a JSON expert. That's why I brought Darryl on, though I'm planning on learning fast. I believe that recently I read about how they're starting to introduce the idea of JSON schemas, which probably means that people will get mad at JSON and move on to something else, since the whole idea for a lot of people was, I don't want schemas, I don't want any sort of constraints. So I think there's something going on in the JSON world to start to implement schemas, but I don't think that we're currently working with them in the database.
Yeah, it kind of defeats the purpose of having unstructured data if you put structure on it, but who am I to say? Another thing you can do with JSON objects is you can add values to the end. In this particular case, I'm going to add a key called nickname, and I'm going to put the value as the king. And another interesting behavior is put is an upsert. I found this out the hard way one time. If you try to put an object in there and it's already there, it will update it. But if it isn't already there, it will add it to the end. You can also interrogate an object to see if it has a particular key. In this particular case, I'm going to look for the key called age. And if it does have it, then I'm going to change the age to be 22. Of course, since you can put entries, you're also allowed to remove them. So in this case, I'm going to remove that age key. And last but not least, I'm going to actually rename a key from nickname to reality is. Of course, I have to run the whole procedure, not a single line. So there's the output from that.
Nice. Now, with JSON and SQL, like as of 12.1, you can query things out of the database. You don't need the PL SQL object types to do that. What if I wanted to update a value within the JSON document? Is there a way to do that with an update statement in SQL?
Yes,
directly?
it has to be done the hard way. You have to extract it, manipulate it, and then put it back.
So that's pretty much one of the main use cases for the PL SQL API, right? If you want to change that document and you want to do more than simply replace it with another, well, you will replace it with another entire document, but the way you would use the API is to grab the document out of the database and then be able to parse through it and find the pieces you want to change, make changes, and then push it back.
Correct.
And you could have done that even in 12.1, but you would have had to either use some other utility or you would have to know how to look through that JSON document and parse it yourself. So what we're doing here with this API is giving you a way to very intelligently and securely and confidently move through these complex structures, make the changes you need, and then push it back to the database if that's where it needs to go.
Very true. The remove statement is forgiving. In this particular case, I'm going to try to remove a key that is not even there. And it still displays the value.
Just like a delete.
Correct. Rename is not so unforgiving. Here I'm going to try to rename a key that is not there within the JSON data. And it tells me that it's not there. So of course in these particular situations you can use PL SQL to simply track that exception.
You probably meant to write signing off, but I like singing off.
Don't get me started. So this will throw that same error when it tries to rename a key that isn't there, but the exception handler will suppress it.
Which you only want to do with great care. If you do want to say when that exception then null, you might want to put in a comment saying why you're going to ignore it. Just a thought.
Oh, very true. All right, now we're on to the last set of demo scripts, and oh my god, I might actually make it through a demo. This one is more in-depth on JSON Array T, which is aptly named because it handles JSON arrays. In this particular case, simply an array of numbers, 1, 2, 3, 4, 5, and this one is an array of actual JSON key pairs. Not much to show here, just want to prove that it compiles if I run the whole script, not the single line. There we go. Arrays can also be parsed. So I'm going to build these arrays and then call a procedure called parse me, which is up here. The first thing it's going to do is show the size, and then it's going to navigate through the particular elements in the array and display their values.
And it's always worth reminding people that arrays in JSON and JavaScript and many other languages start at 0, as opposed to our arrays, like nested tables, that start at index position 1.
Very correct. So here I have for counter in 0, and then I go to the actual size of the array -1. One thing that will trip you up is you have to remember that JSON arrays in JSON start at 0, but the JSON key list PL SQL table, that actually starts at 1. So I'll run this code, go check the values, and sure enough, the first array was a size of 5, and then it displayed all the values, and the last one was a size of 2. But you'll notice it didn't actually display any particular values there. That's because these are actual JSON elements. You can't do a simple get string on JSON elements because they're not actually strings. But if you remember the on error behavior, for the default value of 0, it simply returned null. Parsing can get a little more in depth if you want to actually check those key JSON key value pairs within the array. So here I'm building that array, and then I call parse me, which is up here. First thing I do is I output the size, and then I loop through them. And then because I know what the JSON looks like, I can actually know that the first thing I'm going to see is an element. I'm going to load that into a JSON element T object. I'll put the string value just for demonstration purposes. But I can't actually interrogate the element to find out what keys it has. I have to go up to an object. So I've had to take that array element and turn it into an object to get the keys. And then I'm going to output the key name, doing a get string on the particular key number. And here's the output way down here. So the parsing can get quite convoluted and complex, even if you actually know the structure. In this case, I know it, and it still took quite a bit of code to go and find the values. You can append elements to the array. In this particular case, I'm going to append a D to the end. You can actually put values in there as well. So I'm going to put the value BBB at the array element of 1. And here, I'm going to put the array value of BBB at element 1. But notice that at the end here, I specified true. That will become clear when we show you the output.
Ah, the mystery.
So here, I simply appended the D. And this one here, I put a value of BBB at element 1. But because I specified false, which is a default value, it simply pushed the rest out to the right. For the last call, at the end, I specified true. So it actually overwrote the value of B with BBB.
Can you go back up for just a second? So when you change the value of VArray, and show the output again? So in the first call to put, you just pushed it out. And I guess my question is, you then did the comma true to replace, but weren't you at that point replacing something that had the 4 elements? Why does it just show 3?
Nope.
You're rebuilding it each time. Sorry.
Yeah.
Got it. Okay.
Don't worry. I struggled with that in my first set of demos too. Lost a little bit of hair on that one. You can also put null values, very similar to put. So here I'm going to put a null value at element 1. And here I'm going to put a null value at element 1 as well. But notice that I specify true on the end. So when you run this code, for this particular entry where I didn't specify overwrite, it put a null right in the middle, but it pushed everything else out. In this particular case, it just overwrote that value with null. And that, I believe, is the end of the demos.
Nicely done. 45 minutes into our hour. All right. So what's your takeaway generally on using the PL SQL object types and your experience with them?
They're very easy to use. Although they can get convoluted if you need to do parsing, as I showed there, where you need to go from an array to an element and then back up to an object just to simply get the list of names within the JSON. So it can get pretty convoluted, and it's fairly easy to get lost. And if you didn't know the structure, it would perhaps be a little bit tough to debug any problems. So one thing I always find myself doing is when I'm initially writing code to parse any sort of JSON, I always set that on error to 1, so I at least have a good idea of what's going on, and I don't get left thinking, oh, hey, it worked, when it really didn't.
Yeah.
Another feature that I'm finding really handy that I hope to do another code talk on later is the JSON data guide, where it actually tells you the structure, and you can simply use that to navigate through. I anticipate that will make all of this a lot more usable.
And that was introduced in 12.1, wasn't it, originally? Or is that new to 12.2? Okay.
12.1, but PL SQL packages to actually utilize it are much better in 12.2.
Okay. And I have a question here. Oracle could have used the object member function for JSON, which would have made the developer's life easier. I guess it's a statement, not a question, but it seems like, does that make sense to you? It seems like we are using object member functions for JSON.
Yeah.
So Parthiban, what do you mean by that? It seems like the object types that Darryl has been presenting do use member functions and procedures to get the job done. So probably there's something to your question I'm not yet getting. Feel free to ask it again or differently. And we'll take other questions as well. We have several minutes left to the hour, and now's the time. And while they're assembling their questions, what I will do is grab back the screen. And show my screen. I think I'm showing my screen now. Hope so. So what I wanted to do is make sure you're aware of my blog post. So I had mentioned in terms of getting access to the blogs, the resources on JSON. So this is my blog. Hopefully everybody can see it. And I've also created a bit.ly for it. So this is something you should be able to write down pretty easily. But anyway, Stephen Feuerstein on PL SQL, blogspot.com. If you search for JSON, you'll find a JSON post in which I simply list a number of resources to help you get started. So there's a lot going on here with JSON in the database, and obviously we're not talking about the SQL side at all. But this will give you links to the documentation, to the live SQL tutorials, to the existing blog posts that we have out there. And it'll be a great way for you to get going on JSON in the database. Okay, let's see, what have we got for more questions? Can you get out-of-bounds errors in JSON when dealing with arrays?
Yes, it does return out-of-bound errors.
Do you have an example you think you can show us?
Not something I'm willing to say right now.
Okay. And other questions? Looks like we're running. So let's go over your resources. And then we'll finish up. So Darryl, why don't you tell us about what you've been doing and where people can go to get more information on your JSON-related resources?
The main source point of contact is Implestrat on Twitter. And from there, you can get links to all of my blog entries on implestrat.com. The site was originally going to be a site set up for consulting, but it's gradually become simply a research site. And the main thing that I'm researching right now is JSON and how it behaves in Oracle.
All right.
I've also done a lot of posting onto the live SQL site for Oracle code, and I will upload all of these examples hopefully in the next few days. And the PL SQL Challenge, or Dev Gym, I think it's called now.
Yes, it is.
I'll also be uploading some of these examples onto there so you can confirm and test your knowledge on that site.
So if any of you are not already aware of it, let's see if I can grab my little pointer pen. So devgym.oracle.com is the developer gymnasium. It's the place where you can go to exercise your SQL and PL SQL skills and more general Oracle database skills. And soon, Java skills. We'll be starting a Java quiz, hopefully in a month or two. So it gives you a way to actively engage with the technology. You can take quizzes, workouts, and classes and kind of deepen your knowledge in these different areas. All right, so lots of resources for you. Follow Darryl, keep up with what he's doing. Follow me, so as I post more on JSON and beyond, you'll catch up, you'll keep up. Check out the blog post on JSON resources, and that should give you a great start and access to the product manager, the developer beta, who is also very active on the blog, to give you information about how to leverage this functionality most thoroughly. Let's see. Oh, I think I've got some other questions coming in. So this goes back to the question about using the object member functions. So we have a clarification. What I meant was we could have used the name of collection methods such as delete exists prior. Oh, I see. So the point Parthiban was making is that we have existing methods already defined for collections, nested tables arrays, and associative arrays, and V-arrays. And so what he was saying is, why not have used those same names for the methods within the JavaScript object notation object types? Interesting point. Probably the folks who were designing those object types were thinking more about making those APIs similar to standard JSON APIs, though I can't say for sure since I don't live in the JSON world. But I would guess that they were looking at having more familiarity or consistency with that side of the world. But it's an interesting idea. I might pass that along to the developer in terms of adding them in addition to the others so that you have that name compatibility. More questions? When processing JSON data, would you recommend loading the JSON data into collections, or should I process the JSON objects directly?
Process them directly. Bringing them into memory and holding them there takes a little bit of extra time.
Okay. And when you did the put or append, is that actually updating the variable or just the output to the screen?
It updated the actual variable.
Yeah. But the thing to note there, and perhaps it's part of the thinking behind the question, is that if I grab a piece of JSON data from the database through SQL and read it into my local variable, if I make changes there, I'm not changing what's in the database at all until you actually do an explicit update, insert, or delete with that JSON information in the table. Nothing's changed in the table, just inside your session memory. All right. Let's see. Did you see any issues on caching JSON objects in the OSB result cache? Do you know what the OSB result cache is?
Yeah. I can't imagine there would be any issues. It would simply be seen as values in a particular row from a particular object. So no, I can't see any problems.
What is the OSB result cache?
I don't know what the acronym means, but it's a particular cache where it records results. So if you run the exact same query again, it simply goes to that particular cache to find the result rather than querying it all again.
Oh, you mean the query and the function result cache in the database?
Yeah.
Okay. Right, so if that's, yeah, so that would be the function result cache. So the issue there is that it all has to do with the parameter list. So if you're manipulating JSON objects inside your function in the database or not, it all depends on whether or not the table changes. If the table changes that the function result cache dependence on, it will affect the caching. But it's not caching the JSON objects. It's caching the data that's being returned by the function. And it will not cache object type instances. So if you have a function that returns one of these object types, like a JSON object T, that will not be cached. That's not supported for caching. Records, individual scalar values, collections, but not object types, so far as I know. If you have a large JSON document and you add something to the start or middle, will it have to recreate the data after where it's appended?
In the scenario where you query it out of the database and then manipulate it and then put it back, it basically puts the whole thing back.
Right, so definitely in terms of the interaction with SQL, with the table itself, it's a complete replacement. In terms of the data in memory, if you add something to the start or middle, will it have to recreate the data after where it's appended? I think the answer generally would be no. It's either pushing it, it's all being handled by the API.
Correct, it just pushes it out.
Yeah. How do you import and export JSON documents into or out of the database?
You just use standard Oracle data pump to take it out or put it back in, because if it's in the database, it's just another column in a table. It can be a blob column or a clob column or a varchar2 column. The only thing that's added is you put an is JSON constraint on it to tell the Oracle that it is JSON data. And all that really does is just tell Oracle to not allow invalid JSON data into the column. Other than that, it's processed the same as any other column.
Right. So we didn't add a new JSON object type. It's just a clobber of arcar2. And therefore, not that all those features wouldn't work if we added a new object type, a new type, but because it is literally the same type of data we've already had and supported, there should be no difference in terms of all your strategies for managing that data. All right, we got another one coming in. What about while processing? Oh, then Thomas said, okay, so maybe we've got that answered since I don't know what that question means. All right, looks like, what is the difference between Apex.json and this API? Have you worked much with Apex.json, Darryl?
No, I haven't.
I've only worked with it a very little bit, and the pieces that I've seen look actually quite familiar. But we're not in a position right now to give you a detailed comparison of the two, and it could be that a search will give you that. I imagine there's a fair amount of similarity to it. All right, well, we're at the top of the hour. Thanks very much, Darryl, for your presentation and your knowledge and sharing that knowledge with the community. Thanks for everybody for attending and for all of your questions. Sorry, Darryl?
I'm just saying thank you for having me.
You're very welcome, and it sounds like you're ready to come back to do more later this year, so that's pretty cool. We'll do it on the JSON Data Guide feature. Fantastic.
Sounds good.
All right, thanks everybody, and do follow Darryl on Twitter, follow me on Twitter, check out our resources and get up to speed on this technology. It's going to be critical to using the database in the future, for sure.
Thank you, Stephen and Darryl.